Today we are going to discuss reproductive physiology revision series. So first we are going to start with male reproduction. So in male reproduction, mainly we need to see what is male reproduction physiology. So mainly for the development of male gonads, there should be presence of SRY gene, which is mandatory. So mainly for the production of gonads, we need SRY gene, and this SRY gene is mainly the sex determining region of Y chromosome, and also it presents on the short arm of Y chromosome, and also it codes for transcription factor known as testis determining gene product. So testis determining gene product mainly stimulates the testis, and in turn it has mainly which stimulates it mainly by means of two types of cells. One is the Leydig cell and another one is a Sertoli cell. So Leydig cell mainly activates the testosterone, which activates the Wolffian duct stimulation, especially in the male. Whereas coming to the Sertoli cells, they activate anti-Mullerian hormone, that is a female hormone. So in the male, we need to get the male character, so we need to suppress the anti-Mullerian hormone, that is a female hormone. So this inhibits the Mullerian derivative, that is female hormone. So whenever there is presence of SRY gene, we can say it's male. Whenever there is absence of SRY gene, we can say it's completely female. So SRY gene analysis is mainly done for sex determination. Now next, let us see puberty. So puberty is where the gonadotropin releasing hormone is secreted mainly from our hypothalamus, and this GnRH is secreted continuously before puberty, and this inhibits the release of mainly FSH and LH. So before puberty it is always continuous, but most important event marking the onset of puberty is the pulsatile secretion of GnRH. This can release both FSH and LH from the anterior pituitary. So you can see at the beginning, as the GnRH secretion is continuous, FSH and LH are inhibited, but later as it has come to pulsatile secretion, especially in puberty, now there is release of both FSH and LH, especially from anterior pituitary. So before puberty, the pulsatile release of GnRH is inhibited mainly by two substances which are negatively inhibiting it, that is GABA and also melatonin. So at the puberty, we have pulsatile secretion, and mainly this is activated one protein, that is kisspeptin. And this kisspeptin is a receptor especially on the GnRH neuron, and it is called as GPR54. So GPR54, you can see at puberty the pulsatile secretion is activated mainly by kisspeptin, and this receptor is present on GnRH neuron, and this is called as GPR54. So the receptor for kisspeptin is GPR54. And the peripheral signal. The peripheral signal is adequate body fat stores are leptin, and this leptin mainly increases kisspeptin. This is mainly seen in the puberty, and this action of leptin is called as permissive action, because in the presence of leptin only you can see there is increase in this peptide. So this is a permissive action. Leptin is showing a permissive action. And next, let us see the spermatogenesis. So it mainly occurs in our seminiferous tubules of testes, and the duration of spermatogenesis is 74 days. So to complete this cycle, we need 74 days. So what happens in this spermatogenesis process? Let us check out. So we can see first we have a stem cell that is called as primordial germ cell, and that primordial germ cell is producing a spermatogonia, and this spermatogonia divides into type A and type B stem cell. And the type A stem cell, again it remains like that, but the type B stem cell is coming from the primary spermatocyte mainly by means of mitosis. And next, this primary spermatocyte is in diploid condition, and by means of reduction division, also called as meiosis 1, form the two secondary spermatocytes, and these two secondary spermatocytes lead to formation of each secondary spermatocyte give rise to two spermatids. Means here we can see two secondary spermatocytes, right? So it will form four spermatids, and that four spermatids, each spermatid form one mature sperm. Means we are getting completely four mature sperm. This process is called as spermatogenesis. So this whole cycle process is called spermatogenesis. For the conversion of this spermatids into mature sperm is called spermiogenesis. And at the end of cycle, 4 spermatids are haploid, are formed, and release of mature sperm. This process is called spermiation. So now let us see what are the cells in testes. So mainly we have two types of cells. The first one is Leydig cell and next one is Sertoli cells. So Leydig cells are mainly regulated by the luteinizing hormone, androgen, release testosterone, and the Sertoli cells have many functions like it provide nutrition to the developing sperm. So they are also called as nurse cells, and they also lead to formation of blood testis barrier that is mainly formed by adjacent Sertoli cells. And also for adequate, this blood testis barrier is mainly for the protection and development of the sperm from the blood constituents, and also produce androgen binding protein. And this Sertoli cells secrete aromatase to form the estrogen. So even in male there is estrogen mainly because of aromatase, and secrete anti-Mullerian hormone and inhibin which decreases the FSH, and also phagocytosis to remove the dead sperm. So now let us see what is male sexual act. So here we have mainly the 3 steps, that is erection of penis and ejaculation, and also we have the detumescence. The first one is under mainly control of parasympathetic nervous system, and the root value is S2, S3 and S4, and the parasympathetic system mainly release acetylcholine and nitric oxide. This nitric oxide is released as a part of non-adrenergic, non-cholinergic system, in short form NANC, and both acetylcholine and nitric oxide cause dilation of arterioles, and also they are leading to compression of veins. So by this there is erection. And we have cyclic GMP, which is a second messenger especially for nitric oxide, and this is degraded by phosphodiesterase 5, in short form PDE5. So PDE5 is mainly inhibited by sildenafil. So when this is inhibited, it can promote more erection. So therefore prolongs the action of nitric oxide and prolong the erection. And next we have ejaculation. So it is mainly controlled by sympathetic nervous system from T12. The root value is from T12 to L2, and it involves mainly emission and ejaculation. So this process is again divided in 2 types. Emission is the movement of semen into the urethra due to the contraction of mainly vas deferens, and ejaculation is the movement of semen out of urethra. And next we have the detumescence. It's actually a stage of resolution due to the constriction. So at the beginning we have seen erection is due to dilation, but this detumescence is mainly due to constriction of arterioles, mainly mediated by norepinephrine and endothelium. So next let us see what are present in semen. So it has a sperm and a fluid component with a pH of 7.4, and the normal count is 90 to 120 million per milliliter. So it acquires motility in the epididymis, and the sperm acquires the calcium channel called cat spur, and undergoes capacitation, undergoes acrosome reaction, and also penetrates the zona pellucida of the ovum, and it can fertilize the ovum, occur in the female genital tract. Next let us see what are fluid components of semen. So mainly the bulk of it is coming from the seminal vesicle, that is 60%, and from prostate 30%, and from vas deferens 10%. So the secretions of seminal vesicles are mainly fructose for the nutrition, and it is mainly transported by GLUT5 transporters, and antioxidants, vitamin C, prostaglandins, phosphorylcholine. These are all which are released from the seminal vesicle, and this phosphorylcholine is used as a detection of seminal stains mainly by fluorescence test. So fluorescence test used for detection of phosphorylcholine, which is released from our seminal vesicles 60%. Next let us see the secretions of prostate gland. There mainly we have fibrinolysin. It causes liquefaction of the semen, and also acid phosphatase, and also spermine, which is identified by Barber's test for the detection of seminal stains. So we are using 2 steps here. For the fluorescence test using phosphatidylcholine, which is released from seminal vesicle, whereas another test is for spermine, which is Barber's test for the detection of seminal stains, which is coming from the prostate 30%. And the last one is vas deferens, only 10%. It's coming from that. So this is all forming some liquid material in the semen. So buffers in the semen are mainly bicarbonate and phosphates. And next, let us see the regulation of male reproduction. So two cells and two generation model is what we have. So mainly GnRH is coming from our hypothalamus. It activates the anterior pituitary. So anterior pituitary releases both LHL and FSH. LH mainly activates the Leydig cells. They release the testosterone, whereas FSH activates the Sertoli cells. They release the inhibin. So you can say this testosterone is acting as a negative feedback either to the anterior pituitary, or also it can act as a negative feedback to the hypothalamus, and this inhibin also act as a negative feedback for the anterior pituitary and also GnRH. So negative feedback is testosterone inhibits luteinizing hormone, and inhibin inhibits the FSH. And next, let us see the hormones which are released. It is nothing but testosterone. Its action include development of Wolffian stimulation, development of internal genital organs, increase in muscle mass, particularly in males. So that is the reason males have more muscle mass when compared with female because of this hormone testosterone. And also there is increase in RBC, particularly in male. And next, coming to dihydrotestosterone, that is DHT. So testosterone is converted to DHT by 5-alpha reductase. So this DHT levels increase mainly during puberty, and the functions is growth of external genital organs, prostate growth, and conditions like benign prostatic hyperplasia. 5-alpha reductase inhibitors can be used for the treatment, like we have finasteride. It's used for the treatment because it's benign prostate, so to remove that benign condition. So by this we completed the male reproductive system. Next we'll move on to the female reproductive system. Before that, from the bits and also from the textbook, I have found some important points, like the adrenal gland releases minimum 5 androgens, and the half-life of testosterone hormone is like 30 minutes to like few hours. And the adrenogenital syndrome is where in a young boy there is growth of both axillary and pubic hair. So it's so surprising that in a young 8-year boy, if there is axillary pubic hair, that is because of adrenogenital syndrome. Hence there is some problem in the adrenal and genital axis. Adrenal gland also produces this androgens, all this, right? So if there is some abnormality there, this will lead to this condition. And in male, 80% estrogen. In male also estrogen is produced, that too 80% is produced, especially by Sertoli cells. And in fetus, the testosterone development is like about 7 to 10 weeks or more weeks after the birth. And luteinizing hormone is the primary stimulation for testosterone secretion, and FSH mainly stimulates the spermatogenesis. And gonadotropin releasing hormone GnRH mainly is a protein hormone with 10 amino acids, and this GnRH is mainly releasing from the arcuate nucleus, which is present in our hypothalamus. And next, this GnRH is also known as luteinizing hormone releasing hormone, very important. And whenever there is decrease in male sexual function, this is known as male climacteric. And prostate cancer can be decreased by usage of estrogen. And adipose genital syndrome and hypothalamic altruism, Froelich, these are the different names of a disease where an adult male is having still the childhood sex organs. Then this is called as adipose genital syndrome. And also the adult male voice is also different, like having still childish voice and also having some fat, extra fat, like obese. And this is also what is hypothalamic eunuchism. So this is all about male reproductive system quick revision. Next we'll move on to the female reproductive system. We are going to start the female reproductive system revision series. So this is the revision continuation series. So 2-cell, 2-gonadal trophin model is present even in the female reproductive system. So here mainly the gonadotropin releasing hormone is released from the hypothalamus, and this hypothalamus mainly stimulates the anterior pituitary, of course, and this anterior pituitary releases luteinizing hormone and follicle stimulating hormone. This luteinizing hormone acts upon the theca cells, The follicle stimulating hormone acts on the granulosa cells. So either from the theca cells or granulosa cells, they both together form the androstenedione. And this androstenedione, in the presence of aromatase enzyme, it gets converted into the estrogen. So this is how estrogen is formed from both luteinizing hormone and follicle stimulating hormone. And the main stimulation is by our means the mainly it is produced from our hypothalamus by gonadotropin releasing hormone acting on the anterior pituitary and producing them. Next you can see the aromatase enzyme. So the aromatase enzyme, which is produced mainly by granulosa cells, convert the androstenedione into the estrogen. Now let us check out the menstrual cycle in female. So menstrual cycle, there are cyclic changes especially in the ovary, endometrium, cervix and vagina. So see, ovary, endometrium, cervix and vagina. So here we'll see the cyclic changes. So first we'll check out the ovarian cycle. So ovarian cycle is mainly having different phases like follicular phase. After that there will be ovulation, especially on 14th day. Next we'll have the luteal phase. It's always constant. Next we'll see detail of follicular phase. So here mainly there is, in the name itself you can find it, follicle phase means follicle is growing. So there is a growth of ovarian follicle, especially on the under the influence of FSH, that is our follicle stimulating hormone. So this is the first hormone to rise in this follicular phase, and it mainly stimulates 15 to 20 follicles, and among this 15 to 20 follicles only one follicle becomes the dominant, and that dominant follicle is called Graafian follicle. And the dominant follicle mainly has maximum FSH receptors and also has the highest aromatase activity. So whenever there is aromatase, it will easily convert into estrogen. So there is highest level of estrogen. Next let us see the estrogen, which is the second hormone to rise. It's the highest level mainly seen during before ovulation. Now let us see the phase of ovulation. Ovulation mainly increase in estrogen, increase in LH. So you can see in ovulation actually, as the estrogen has increased, this estrogen will give a positive feedback to the luteinizing hormone. So as there is more estrogen, even the luteinizing hormone will increase. So this is a positive feedback. And the luteinizing hormone is our third hormone to rise. So the first hormone to rise is FSH, the second hormone to rise is estrogen, and the third hormone to rise is LH. And LH surge is going to happen 36 hours before ovulation, and LH peak is going to take place 8 to 10 hours before the ovulation. So these are the times we need to remember at what time LH surge happen, at what time LH peak happen. And around the ovulation, the body temperature rises like about 0.5 to 1 degree Fahrenheit. And the FSH surge also occurs along with this LH surge. Then also to mainly lyse the follicular wall and release the ovum. So this is how the ovum is released out. Next we'll see the luteal phase. Luteal phase is just after the ovulation. The Graafian follicle is filled with blood. So now as the follicle is filled with blood, this is called as corpus hemorrhagicum, because the blood is present in now this follicle. And the blood cells later clot and they are replaced by luteal cell, and this is called as corpus luteum. These luteal cells are yellow in color, so hence the corpus luteum looks yellow color. And the corpus luteum mainly produces the hormone progesterone under the LH stimulation. And 10 days after the ovulation, that is at the day 24, if fertilization doesn't occur, then this corpus luteum start degenerating. And remember that progesterone is our fourth hormone to release. So first hormone FSH, second hormone estrogen, third hormone LH, fourth hormone progesterone. Next let us see the endometrial cycle. So we have three phases: proliferative phase, secretory phase, menstrual phase. So proliferative phase is from the day 6 to 14, where endometrial thickness is increased, uterine glands lengthen. And secretory phase is from day 15 to 28. Here endometrial thickness is reaching its highest value, and the uterine glands are secreting mainly some clear fluid secretions. And the menstrual phase is from the day 1 to 5 days. It's where superficial 2/3 of endometrium is shed, and it's mainly supplied by spiral arteries. So this undergo constriction and degeneration of spiral arteries due to mainly PGF, prostaglandin F2 alpha factor. So because of this there is blood loss. And next we'll see the cervical and vaginal cell changes. So in cervical mucus, what happens is they become thin under the influence of estrogen for smooth passage of sperms. And the mucus is thinnest especially around the ovulation time, and the mucus is thickest under the influence of progesterone. So next, vaginal changes. Here we mainly have superficial cells and intermediate cells. In superficial cells especially under the estrogen influence, and intermediate cells especially under progesterone influence. Next, let us check out the hormones. Mainly we have female sex hormones. They are divided into either steroids or protein hormones. Steroid hormones are estrogen is a major one, and next comes the progesterone. Estrogen is actually a C18 steroid. And next the protein hormones are mainly inhibin B, activin and relaxin. So actually estrogen varies according to the age of the female. If the female is like in reproductive age group, then she will have estradiol, which is E2 form of estrogen, and in pregnancy time the female will have E3, that is estriol type of estrogen. In menopause time the female will have E1 type, that is estrone. So now let us move on to the functions of estrogen. So mainly estrogen on uterus, it has estrogen is priming the uterus so that uterus become more excitable, more contractile, and increase gap junctions and increase sensitivity of uterus to oxytocin by estrogen. And in breast, the growth hormone of breast increase the ductal growth of breast in the presence of estrogen. And estrogen is also responsible for secondary sexual characters development, and mainly in the bone, estrogen leads to prevention of bone resorption. So it's a bone friendly hormone, means estrogen is useful for building up of bone. And normally the rank ligand induce the differentiation of osteoclast, that is bone resorption, but rank ligand is inhibited by osteoprotegerin, which is released from estrogen to prevent the bone resorption. And in kidney, estrogen is like a steroid hormone, right? So it also does like almost all steroid hormones, that is sodium and water retention. Next, going to progesterone. Progesterone is C21 steroid. Its functions are mainly in the uterus. It is anti-estrogenic, that is it's opposite to estrogen. So it is of course makes the uterus less excitable and less contractible. And in breast also it will lead to lobular growth. In central nervous system, progesterone is mainly central nervous system depressant, and the thermogenic action is around ovulation, and body temperature rises same like 0.5 to 1 degree Fahrenheit. And in kidney, sodium and water excretion, so you can see it's reverse. Progesterone is reverse function to estrogen. Estrogen will do sodium and water reabsorption, but progesterone is reverse. It resembles diuresis, of course. If excretion of water and sodium is it leading to diuresis, and progesterone is only unique hormone inducing diuresis among the steroid hormones. Next, let us see the protein hormones like inhibin B. Inhibin B is a major regulator of FSH, decreases FSH by negative feedback, and activin increases FSH. So in the name itself you can say it's active, it's inhibiting. So it inhibits FSH, activin increases FSH. And relaxin relaxes the pubic symphysis and dilates and softens the cervix during delivery especially. So relaxin is useful for the delivery of baby. Next, let us see lactation. In lactation, mainly we have mammogenesis, that is the growth of breast, especially in the presence of both estrogen and progesterone, because estrogen will lead to tubular growth, whereas progesterone will lead to lobular growth. Estrogen will lead to ductal growth, right? And lactogenesis, in the name is genesis, formation of milk, right? Production of milk, of course, by presence of prolactin hormone, which is coming from which is a twin hormone, we know, along with the growth hormone, right? And next comes galactokinesis. It's a milk ejection done by our oxytocin. So you can say this prolactin hormone is coming from anterior pituitary, oxytocin is coming from posterior pituitary. And the milk ejection is a neuroendocrine reflex. So this is a complete revision of our reproductive physiology. So don't forget to like, share and subscribe our channel if you like our videos, and also try to share with your friends if you understand this topic.